Let's look at how to apply some frequently used React hooks with TypeScript. Hello and welcome, I'm Dave. In today's lesson, we'll be looking at how to use React hooks with TypeScript, and I'll provide links to all resources in the description below. I'll also provide a link for you to join my Discord server where you can discuss web development with other students, and you can ask questions that I can answer and receive help from other viewers too. I look forward to seeing you there. I've already started up a new React and TypeScript project with Vite, and for this tutorial, I'm assuming you're already familiar with some common React hooks that I'll be covering, but should also be a bit of a review. And if you need more info on any of the React hooks, I'm going to include links to the tutorials I have for each hook in the description below. Okay, let's start out here in our app component, and let's bring in useState, which may be the most frequently used hook of all. So we'll have useState. And that comes from, if I could spell from, I'm already issuing some typos here, comes from React. After that, let's go ahead and apply useState. So let's just do our typical count at first. So we'll have count and set count, and we'll set this equal to useState, and we'll just start with the 0. We don't see any complaints from TypeScript at all, do we? That's because you can just leave it this way. It uses inference. Instantly, it knows that count is going to be a number, and we can see that through the IntelliSense. However, we can be explicit if we want to. So when we're providing a number or a Boolean or a primitive like a string, we could just put it here inside of our arrows and say that, yes, it is definitely going to be a number. Or what if we were waiting on some data and it might be null as well? And if that was the case, we might put in a union type and say this was null, and then we were waiting to get that data here like this. So we would have our beginning state as null, and then we could provide this union type. Or let me declare an interface here at the top. I'll create one, and I'm just going to paste this in quickly. It's an interface for a user, and it has an ID of number, and it has a username that is a string. So we could say this is going to be a user or null, or what if this was going to be an array of users? So we might have an array of users here. Once again, this might be null before we would get that array, or maybe we would decide to just start out with an array and not have our null here. But you can see it pretty much works all the same way as you would expect, and it can infer a lot of this as well. But if we have an interface like this, it would be good to provide that. And of course, my example here is not matching up with count and set count, and I put in a user. But just to continue this example quickly, I want to show one other thing you may see that I don't necessarily recommend, but I want to show it because you may see it. And you may see an assertion, so it would have an object like this because that user is an object as well, and then you could have as user. Now, you're essentially lying to the compiler when you do this, saying that, hey, we're going to have a user here, so view this as a user. You would only do this if you knew you were going to fill this state very quickly, or it could cause some errors. But I did want to show this assertion possibility because you may see that in some code. So for now, let's switch this back to a number as our example, just a basic one, and then here we'll have a 0 in here for the beginning state. And then I'm just going to copy this down for state and create that second state, which is user. I'm going to highlight count, press Control D to select the next count, and I'm going to type users. So I now have users and set users. And I've got a short on my channel that shows what extension I'm using that goes ahead and keeps that case preserved with the lowercase and the uppercase, if you want to check that out. But over here, then, I'm going to switch this back to using the interface of user, and it's going to be an array of users. And then I'll put or null, and I'll start out with some null data. So it gives you examples of both. And now we can pull this into our example for the second hook I want to cover, which is useEffect. So let's bring that in at the top as well. Let's bring in our basic useEffect setup here. So we'll start with useEffect, and it has a function inside. After that, it's going to have a dependency array right here at the end. And now with our dependency array, we have a basic setup for useEffect. Now, useEffect is dealing with side effects, so it doesn't really return a value. And so when it comes to TypeScript, there's really nothing to do unless you're returning a value. And this also applies to the hook that is seldom used, useLayoutEffect, because they both have the same structure. So there's no real TypeScript application here, but let's go ahead and review the hook just a little bit, because this is going to run when the component mounts. So we could have console.log and we could say mounting. And now with React 18, there's a change that some are not aware of yet, and that is when you use strict mode, which only applies to when you're in development mode. So when you're using strict mode, it mounts the component, and then it unmounts it, and then it remounts it again. So you're going to see this mounting behavior twice here. This console log should log twice because it's going to mount, unmount, and remount. Now, useEffect does return a cleanup function. And here in this return, we can just have an anonymous function that says console.log, and we could put unmounting, and you would see that once because it would mount, unmount, and then remount once again. So what is useEffect for? Again, side effects. And if you're not familiar with that concept, it's when something changes, you could have a side effect. Something else could happen. It's not necessarily going to return a value, but maybe you want to change something else. So for example, if our user state changed, we could then log something else to the console, which a console log is always a side effect. So we could put users in here in our dependency array, and then if the user state changed, then it would call this useEffect into action once again. This is going to, of course, run once when the component mounts, but after that, it would not happen again unless the user state changed. So here after that, we could just console.log, and we could say users, and then after that, let's just put a comma and log the user state, for example. So a very simple example. Again, really no TypeScript to apply because you're not returning a value. It's a side effect. Now let's look at the hook useCallback. So we'll bring this in at the top as well. Now that we've imported useCallback, let's talk about what it's used for before we apply it. useCallback will memoize a function, so it's not always recreated. And let's look at the JSX here inside of our app component. I'm just going to put an H1, and then let's put the count state that we have inside of that. But what if we had a button element as well? So let me go ahead and create a button here, and it might have an onClick. And this onClick could have a function in it. And sometimes, of course, I'll just put anything I want to here. Let's just put add for now. But sometimes the onClick is just created with an anonymous function. So we might have this and the arrow, and then we could say set count, and we'd set it equal to the previous, and then put our arrow here in previous +1. And that's fine, but this function is recreated every time. And while this isn't a big function and it's not a big deal, of course it would be passed down if we had button as a separate component. It would be passed down into that component. What we can do is take this function and name it up here and wrap it in useCallback, and then it will be memoized. And that can be handy. Some people do that all the time. Some say maybe not all the time, but do it some of the time. So let's go ahead and create one, and you can use it as you want to. I'm going to call this function add2. So we'll just add 2 to our count. And from there, we'll say useCallback, and it's just a normal function. So we'll have our anonymous function here. And then inside of our useCallback, we'll go ahead and say set count, and we'll put in our previous and have that be previous +1. That's all fine. But useCallback also has a dependency array like useEffect. And that means anything that the function would depend on, we would pass in. So if it had something else other than our count here, for example, we would go ahead and pass that in. But we're not going to need to do that because we're using the set count here, and React recognizes that. So we'll just leave this empty, and it will never have to recreate it after it creates it. The first time it will be memoized and saved into add2. And then instead of our anonymous function down here, we can just put our add2 function. And that's typically how you would use useCallback. Now, when it comes to TypeScript, let's look at add2 and see what IntelliSense tells us. it has a function signature. It is void, essentially, and it doesn't really have anything being passed in as a parameter or anything else either. So a very simple function signature. And you can use the inference for that and leave it like it is because, once again, you don't see a complaint from TypeScript. Or you can go ahead and put some of that here. So we could put void right here. And then we could also, let me leave a space here. We could also provide the event if we need it. Now notice, I don't need it inside of this function. But if I did, say I would put in E here, but now TypeScript gives us a warning. Now before React 18, this wouldn't happen. But now it's going to say E is declared, but its value is never read. And it also says parameter E implicitly has an any type. And that's the part I want to highlight. Before React 18, it wouldn't have said that. It would have just given it the any type. But now it's giving you that warning. So you could replace it with any here. However, we can be more specific as well. So again, I'm pointing out my simple function here doesn't really use the event, but let's get more specific just in case we were using that event. And here I can say, instead of any, let me say this is a mouse event, and that comes from React. So we can pick that right out of our IntelliSense menu, and it should have imported up here. And yes, we now have it at the top. But not just that, we can specifically say this is a mouse event for an HTML button element. There we go. And now we've provided a specific event. But of course, we know a button also could be pressed by the enter key. So let's go ahead and make this a union here. And now let's say this is also possibly a keyboard event that should also come from React here, and we should be able to get that in our IntelliSense menu. And I'm going to press Alt-Z so this wraps down to the next line. And once again, this comes from an HTML button element. There we go. So now we've specifically provided the event that could be a mouse event or a keyboard event. By the way, keyboard event should have also imported up here at the top, and it did. And it's based on this HTML button element, and we do have our button down here. But again, in my quick example, I'm not really using that event here. I just wanted to show you the possibility and also highlight the fact that if you do provide the event, you're going to get that warning in React 18 and above that says it implicitly has any applied, unless you tell it exactly what type of events you're looking for. Now, while useCallback memoizes a function, so it's not recreated, useMemo memoizes a value. So let me go ahead and bring useMemo in up here at the top as well. So I'll say, whoops, I need lowercase, useMemo. And after we bring that in from React, we can use it below, but it memoizes a value, and we would use that for an expensive calculation, something that takes a while to calculate and might hold up everything in our component until it had that value. So just for an example, a typical example at least, is the Fibonacci sequence function. So let's go ahead and first create a type for our function. I'll call this fibfunc here. And after that, let's give it a function signature. So it's going to have in, which will be a number, and then it's going to return a number. So this would be the type for our fib function. Then I'll just say const fib, and it is a fibfunc type, and then we'll say it receives that in parameter, which is the number, and then I need an equals there instead of the dash. There we go. Now inside the function, and you may have written one of these before, it's if in is less than 2, for example, we'll just return in. Otherwise, we're going to return, and we're going to call this again. So it says fib and then in minus 1. And then we'll also call it over here, and we'll have fib, and we'll have in minus the dash, now minus 2. So this is an example of recursion where the function is calling itself. Let's go ahead and save that, but it's also an expensive calculation, so this is something we would use memo on. And I'm going to define one more thing, and that's just the number that we'll pass into the function. I'll just call it mynum here, and it's a number. And I'll set it equal to 37. So it takes it a little bit to calculate, but not too long. And we could change that if we want to see the difference. Or when you download the source code from the GitHub link inside of the description for this video, you could change this number and see how long it takes to calculate. I will warn you, if you go too high, it takes a while to calculate, or it may crash your browser. So now let's scroll down here and apply useMemo inside of the component. Just underneath our add to function that we have right here, I'll apply useMemo. So let's just a couple of returns underneath, and I'll say const, and I'll just say result is going to equal useMemo. And now inside of useMemo, we'll have an anonymous function, and then we'll call fib, and we'll pass in my num. Now, since this depends on my num, and we have the dependency array, we'll say if my num changes, then we want to recalculate this function, and that's when it would recreate the result. Otherwise, the result value is memoized. Now, we can also mouse over and see what IntelliSense tells us. When I mouse over result, it knows it's going to be a number, so TypeScript knows that. And if we look at the signature here for useMemo, notice it says useMemo number, and then it has everything about useMemo. So if we wanted to be explicit here, we could actually put number right here beside useMemo, and that's how it would look for TypeScript. Now, just so you can see that change, let me go ahead and put an H2 here in the source code, and we'll just display the result underneath, which should be a number. And again, if you change this 37, I don't recommend going much higher. You might want to go a little lower. You'll see the difference in time it takes to calculate. It could be just a few milliseconds, or the larger the number, it could be a little bit longer, or again, possibly crash your browser. But that is the point of useMemo. If you have an expensive calculation, it takes time to calculate it the first time, but after that, it's already memoized the result. So it takes no time at all to get the result every other time that the component re-renders. And that really speeds up the process if this is an expensive calculation. And finally today, let's look at useRef. So we'll bring that hook in at the top as well. I'll type useRef up here. After I've imported it, let's define a ref inside of our component. So I like to put those after the state. Let's go ahead and put it right here, and I'll just call this input ref. I'm going to set this equal to useRef, and then I'm going to say, well, before we do that, let's just put it like we would normally see it. Say we set it to null to begin with. But I'm going to say specifically, I'm going to use this ref on an HTML input element. So we can be very specific about what we're using the ref on. Now you might be saying, whoa, why isn't this a union type here? Because we've specified HTML input element, but we've started out with a null value. Well, there's a couple of things we can do here. We definitely want to say it's an HTML input element because that's what we're going to reference. But we could use a non-null assertion here. And remember, we do that with the exclamation mark. But there's something else we can do, and that would be just a type guard when we check. And that could be a couple of different ways. One, you could have if, and then you could say not input ref dot current is where you get the value. So that would be one way to check. But another one would be what I'm going to do. And let's just log to the console first so we can see this eventually. And I'm going to put input ref, and then I'm going to use optional chaining here and just say, if current exists, then we're going to log it. I'm also going to say console.log, and I'll put input ref, optional chaining once again for current. And then if it has a value like our text input will, then we'll optional chain that as well. And you'll see how these work. And if we remove them, we can see what happens also. So let's look down in the JSX, and let's put an input that we're actually referencing now. So I'm going to say input, and this input type is text. That's fine. Let's also give it a ref, and here we'll reference our input ref. I'll save that change. Now let's go back up here and look at what TypeScript does if I remove the optional chaining. It doesn't really complain, but that doesn't mean that this couldn't be null at this point. It certainly could. So you'd want to apply that there, and let's see if it's the same with our dot value here. Now TypeScript complains. So when I mouse over, it says object is possibly null at this point. So we definitely want to have optional chaining there, and then there's no problem. Now, if you are familiar with the useRef hook and creating references, you'll know that changing the value that's stored in current, so our text value from our text input will be stored in input_ref.current.value. Changing that value will not make a re-render of our component, But when the component does re-render, say we click on our button down here that adds 2 to our count, for example, that will cause a re-render. When state changes, we do re-render the component. And at that point, we will log to the console what we have here. Current will actually be our element itself, the input element, and current.value will be the value of that input element. So let's open up the terminal menu and we'll go ahead and launch our project with npm run dev. And then we should see Vite start everything. We're at localhost port 5173. I will control and click to launch the application. Here you can see it's not much for an application, but we have our current count. We have our add button that will add numbers. And I just realized I named the function add2 and I added 1 out of habit, so we can go back and change that as well. Let me just drag this to the right. We'll get back into VS Code here. We can close the terminal and it will continue to run. But yes, my add2 function is just adding 1. So let's go ahead and update that with a 2. Save again, and we should see those changes when I drag this to the left. And now let me add 2 each time. So that's fine. We've got our recursion here with the Fibonacci number, and that is memoized. So when we reload the app, it will calculate it once, but then every time we update the state and re-render the component, the number is automatically there. It doesn't take any longer to calculate because it is memoized. And then we have our input here with the ref. Now this will not re-render anytime I type into the input. I can say, hey, but let me go ahead and pull this to the full screen and then open DevTools with Control Shift and the letter I. And we can see it has been logging the ref, which is the input, and then the value that is in the ref, of course, was nothing essentially because we hadn't typed hey in there yet. And then it didn't re-render when I did type hey. So let me go ahead and update the state one more time. And now we see hey because that is the current.value. So we had ref.current.value to get the hey log to the console there. When it first starts out, it should be actually null for the element, undefined for the value, and that's what we see. We also see from our useEffect, we had the mounting, and then we logged the users, which were set to null for their state, and we didn't do anything with that. But then we had that cleanup function from useEffect, and that says unmounting, and then it remounted the component. So we had mounting once again, and it reran the useEffect when it remounted. And so that's what we all set up inside of our code. Let me go ahead and close this and pull this back over. And so just to recap, we covered several hooks today. We had useState, useEffect, useCallback, useMemo, and useRef, all commonly used, and we showed how to use them with TypeScript. Now, there's a couple of other hooks that I know we'll probably get some comments on saying, when am I going to cover those? And that would be useReducer and also useContext. And I plan on covering those in the next tutorial. They're often used together, and I think that is a great way to group them. Remember to keep striving for progress over perfection, and a little progress every day will go a very long way. Please give this video a like if it's helped you, and thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.